thing which is keeping Cisco awake at night, because it's not only about the APIs, which of course is a big ticket item for players like Cisco in the networking industry. It's also about programmability of the network layer, and it's about business analytics. And these are three elements when we think about the IP network and the IP foundation layer that is keeping us as a player in this industry really, really awake at night. Because those three transitions, APIs, programmability of the network, and analytics, have the potential to either completely disrupt the industry and our industry, or to create incredible upside. Why those three elements are important? I'm testing the viability of the Telco 2.0 business model every time I go and meet with service providers in EMER, and actually resonates very, very well. And at least 3 out of the 6 pillars here require some form of extraction of analytics from the network. And many of those data points reside only in the network. It's not only about location, it's about multidimensional identity, it's about the state of the network. Many of the things that are related to core service improvement require direct visibility of network analytics. Many of the embedded communication services, which is one of the pillars from Telco 2.0, require exposure of assets through APIs. And by the way, one of the issues we are trying to understand and to address is why the API exposure model was not a success so far from many of the service providers. I mean, I think the variety of offers since a few years back is pretty wide. How many developers are truly using those APIs today is still a limited amount of developers. So we're trying to understand what we can do better from a technology point of view to simplify life of developers when APIs expose assets. And then it's downstream programmability, putting the fingers in the pie and try to determine the network behavior, not only in the classical way of how the network works with its own control plane, but also putting a programming layer that may make the network behavior more granular and more controllable. So let me skip one slide, but I mean the key question is, if the Telco 2.0 principles resonate well with service providers, and if part of that is exposing APIs, why that didn't work so far in principle, where APIs were way too complex to be used, way too granular in terms of the level of visibility into the network? Was it more a business model issue or a technology issue? Well, when we look at our customers we are addressing out there, research and academia, over-the-top players, we serve over-the-top players as well with the mass-scale data centers, of course, service providers, enterprises. To various degrees, one of the recurring requirements is indeed that of network programmability. Academia slicing their network, doing experimental partitions, and run out new programs out of network partition. Massive scale data center, the need to steer traffic from one place in the data center to another one to basically have SLA on a transaction basis. Service providers, more and more, I mean, we discussed the whole day, so probably I don't have to repeat the story, but policy and analytics to optimize the network performance and to expose valuable assets, and enterprise for virtualization of workloads. The point is that when we discuss about network programmability and open networks, it's definitely a big thing. Like I said earlier, on a $50 billion company, it may disrupt more than half of the business if we don't take it seriously. But it's a different thing to everyone, right? Is it about open flow, for those of you who are in the technical arena? Is it about SDN, software-defined networking? Is it about pure and simple exposure of APIs? So what is truly network programmability? Three approaches out in the industry. I'm trying to simplify, and this is the best of my knowledge, so it's not just a simplification, it's as much as I understand about it. One model is to say, okay, I throw a bunch of APIs on top of my network, and I let you programmers figure out how to use it. This is what you presented earlier. The problem here is that the level of complexity of those APIs and the meaningfulness of this to developers is simply not in line with the developer's expectation. The other model is, well, forget about the networking vendors, right? This stuff will become pure commodity. I throw a controller layer at it, meaning I deliver an abstraction layer. Who cares about the network below? You can plug on the abstraction layer and develop your application invoking network services. The drawback of this model is that it basically equalizes everything to the common denominator. You have different type of devices with different analytics, different counters, different way to represent the network status, different way to represent behavioral analysis of what an end user does attached to the network, and you equalize everything to the common denominator. And the third approach is I don't care about the network. I can basically overimpose an overlay and mimic the network behavior in a completely abstracted way. These are the three school of thought out there. And what we're thinking is, why don't we try to combine it in a little bit more cohesive way? So why don't we think about a network that on one side can be programmed and virtualized in a pretty simple way with different level of abstractions that allow to extract information in terms of analytics, and then use analytics on one side to package them and sell them to content providers, on the other side to look at the network behavior and keep on improving the performance. So virtualizing intelligence and using analytics to keep on reducing the unit production cost and improving the performance of the network. Out there today, for those of you who are in the technology discussion, the mantra seems to be software-defined networking and OpenFlow, and we're taking this very seriously. This is part of the Cisco roadmap. The idea of OpenFlow is basically take the basic of a network, the forwarding plane, and decouple this from what is called the intelligence in the network, the control plane. So that basically you can have commodity, somehow low-cost hardware or commodity hardware controlled by a third-party control plane. And that's a way to program network at the device level. We believe the world of application requires at least another couple of levels of abstraction. A network service abstraction layer, and a management and orchestration abstraction layer. Let me give you a couple of examples of what we mean with that. Management orchestration abstraction layer. Sorry, wrong click. As a developer, I basically ask the platform, give me a virtual container that includes 5,000 virtual machines and gold quality of service from the data center into the network. I'm offering an Amazon-like type of service. As a programmer, I just want to have a simple way of creating a virtual container that includes X amount of virtual machine and required quality of service. Network service abstraction layer. I'm Netflix, or I'm the new Netflix in Europe. And I want to, in one shot, call a network service that allows to take my HD video and pre-position it to the cache engine closest to the end users in that geographical area. So please take HD, push it out to southern Switzerland to 80% of the end users. That's the abstraction of network services, CDN services. The forwarding plane abstraction, you take, as an example, financial trading, algorithmical trading. You want to take packets from a flow and maybe inspect them on the fly, throttle or add new information element on a per transaction basis to meet the transaction SLA. It's a very, very granular way of programming the network. And that's probably a requirement of certain type of application developers. So what I'm trying to say is that the network itself may provide a huge amount of value to application developers, but we want to keep it simple and define abstraction layers that make sense from a business requirement perspective. Simple use case, path redirection. Want to connect data centers, and I want to do it on the fly based on what we call the traffic weather report, so based on the status of the network availability. And instead of trying to do it with the classical protocols, I truly force visibility of resources into the network and communicate back to the data center. A little bit more interesting one is, at the very point in time in the network, we have not only a routing capability, but also processing power, and also storage. Why don't we think about moving some of the applications that require real-time performance physically into the network itself, right? Physically using processing power in the network, storage in the network, to run applications closer to the end user. Online gaming, user interface rendering from the cloud are all things that need to run very, very close to the end user. If I have a way of programming my network, as a developer, I can look at the network as part of the computing platform in a seamless way. Again, that requires a level of abstraction, which is not the granularity of the all good APIs, where I know BGP, bits and bytes. I need a higher level of abstraction. It takes advantage of computing, storage, and networking in the IP platform. So in essence, the more I look into the Telco 2.0 model with our customers, the more I believe analytics, APIs, and programmability are crucial to implement at least 3 to 4 pillars out of the 6 that you guys have developed in terms of the framework. I think that basically shapes the way networks will be designed and conceived in the future. Important elements that have to coexist with a good level of abstraction and simplicity. So SDN, to that extent, is the right framework, and you have the Cisco full endorsement on SDN, software-defined networking, including the open flow elements. What we want to do, based on the feedback we are hearing, is more than that, is to have basically something which allows to have analytics, exposure through APIs, and programmability out of the same context. We're going to see in a while with Axel how some of those elements can be used to drive also a level of network virtualization and simplification, which is very much in line with the business priority of key service providers in Europe. So that's me done, I think, in less than my allotted time. So I'm going to ask for a glass of champagne or something like that.
Thank you. Let's show our appreciation.